Hello everyone and welcome back to the problem of the day maths videos. We're moving on to day 11 today. Okay, so let's start off with the orange questions from day 11. And you can see here, we're going to start off by making some comparison number sentences. Now we've been told that we have to use three symbols, or we have the choice of three symbols to make the number sentences correct. So that first symbol there is a less than, or a greater than, or an equal to. So our first number sentence has 5 times 7 on one side. It has 40 on the other side. And we need to decide which symbol goes in the middle to make it true. If we put a less than symbol in, we need to say that 5 times 7 is smaller or less than 40. We put in a greater than, 5 times 7 should be bigger or greater than 40. And if we put in an equals, we know that means balance. So these should be the same. So 5 times 7, some of you might be thinking, I'm not very confident with my 7 times tables. But remember, we can always switch round the multiplication. And you could do 7 times 5. And I know that most of you are confident with your 5 times tables. If you do 7 times 5, you will reach the conclusion that it is equal to 35. So straight away we know the equal sign can't belong in here because 35 and 40 are not the same. We know that 35 is smaller than 40. So we need to use the less than sign. And remember, with our sign, we've learnt these before as crocodile mouths. They're greedy crocodiles, so the open bit, the big mouth, eats the bigger number. The small bit points to the smaller number. So our less than is this way around at the moment because it's going to eat the 40, point to the 35. Okay, what about the next one? 6 times 2 and 7 times 2. Now this time, I would like you to be able to tell which symbol goes in there without working out what number 6 times 2 and 7 times 2 equate to. Because I think just by looking at the calculations, we can figure out what is missing. Both of these calculations are multiplications, and they're both multiplications of 2. So this just means we have 6 lots of 2 on this side and 7 lots of 2 on this side. Now we know that this number must be bigger because we have one more lot of 2. So without even working out what 6 times 2 is equal to and what 7 times 2 is equal to, I know this side must be bigger because I have one more lot or one more group of 2. So again, I'm going to put in my less than symbol because I know this has one less group of 2. This has one more group, so the hungry crocodile is going to eat the bigger group. Okay? And lastly, we've got a division number sentence to compare. So we have 10 divided by 2 and 12 divided by 2. So this time, instead of looking at how many lots of something, we are looking how many group or how many is in each group when we share it, because division is like sharing into equal groups, isn't it? So here I start with 10, let's say sweets, and I'm sharing it into 2 equal groups. So a group for me and a group for you. So how many sweets would we each get if we were to share that out? But we don't have to calculate what it's equal to, just like above, because again, this one is split into 2 groups and this one is split into 2 groups. Now, if I start with 10 sweets over here and split it into 2 groups, and I start with 12 sweets over here and split it into 2 groups, I start with 2 more sweets. So each group is going to have more sweets in it. To prove it, if I do split my 10 into 2, if we're not so confident with our times tables, remember you can draw it out. You can draw 2 circles, so that's my circle of sweets and your circle of sweets, and I can do my dots, so I can do 1 for me, 1 for you, 1 for me, 1 for you, keep going until I've drawn 10 sweets, and then I count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, we both get 5. So this would be equal to 5. If I were to do the same thing on the other side, as I started with more, I'd have to draw some more lines, and you'd find that we end up with 6 sweets each. So I know that this side is greater than this side. So again, I'm going to put in that less than symbol. And again, the crocodile is going to eat the bigger number. But I could have done that without working it out, as we start with less to share. Okay, that's question 1 done. Excuse me. Let's have a look at question 2. So, there are 50 children in a school. 15 of the children are girls. How many more boys than girls are in the school? So there's a couple of steps to this question. Think about what we know. We know how many children are in the school in total. So I'm going to draw my bar model, which represents the school, and I'm going to label it as 50 children, because I know that, I'm told that in the question. I'm also told that 15 of the children are girls. So I'm going to come along and I'm going to label my bar model with a G for girls and 15. So I know that 15 are girls. The question then asks me how many more boys than girls are in the school, but it does not tell me how many boys there are. Using our bar model now of the whole school and 15 girls, do you think we could figure out how many boys there are? That's right, it's just the missing bar. And we've done lots of these questions over the last 11 videos. So we know that 50 is our whole, 15 is a part, and we're looking for the other part. So we have to do 50 take away 15. I'm going to practice my mental math skills and my knowledge of place value. I know that 50 take away 10, if I partition this number, is 40. Then I take away another 5, it gives me 35. But do write it down to make sure. Good to practice some mental math skills and some bonds. Okay, so now I know there are 15 girls and there are 35 boys. Fantastic. The question actually asks me, how many more boys than girls are in the school? So what do I need to do with my 15 and my 35? Well, let's think about it this time on a number line to see what the question is asking us. So we have 15 girls and 35 boys. If it's asking us how many more, the question's asking us the gap on the number line, how many to get from 15 to 35. Or another way of saying that is the difference. Hopefully that's jogged your memories that we know that a difference is a subtraction. So to look for how many more, even though it's got more in, which tricks us into thinking we're adding up, it's a how many more, it's a gap, it's a difference. So we are simply going to do a takeaway to find out what the difference between 15 and 35 is. So if we do 5 take away 5, got my 5, I take away 5, got nothing left. And if we do 3 take away 1, 2. So how many more boys are there than girls? There are 20 more boys in that school. Well done. Okay, let's move on to question 3 then. So Mr. Patel writes a number on the board. Lee finds half of the number. Kim finds a quarter of the number. And Lee's answer is 5 more than Kim's. What is the number that Mr. Patel started with? This bar model may help you. So they don't give you clues for no reason. I'm going to copy out their bar model. And then we're going to think about how we can label it with the information we were given in the question. So here is my version of their bar model. Now let's go back to the question and see what we were told. So Mr. Patel writes a number on the board, and then actually we've been asked to find out what was the number he started with. So that is going to represent our whole bar. So I'm just going to call it Mr. P for now. So the whole length of the bar is Mr. Patel's number. But at the moment, that is an unknown. Lee finds half of the number. So which of the bars, the red one or the green one, has been split into half? That's right, the red one, because it's in two groups. So I'm going to label this Lee, because Lee found half, so he found just one of those groups. Now Kim finds a quarter of the number. So hers is the green bar because 1, 2, 3, 4, it's been split into 4 equal groups. So I'm going to label the first green box Kim. So Lee found this box and Kim found this box. We are then told that Lee's answer is 5 more than Kim's. So where is that on our bar model? Well, Kim's number stops here and Lee's number stops here. So the gap between Kim and Lee's number, or that black line there, represents the 5 more. And actually that black line is the same as one of these green boxes. So I'm going to label that with a 5 because Lee's number is 5 bigger than Kim's number. But now I've noticed that this green box is a 5. What do we know about all the green boxes? That's right, because they're equal, they must all be 5. So if I now know that all the green boxes are 5, could I go back to Mr. Patel's number and figure it out? That's right, I could do 4 lots of 5, or I could add 5 to itself 4 times. And I know that 4 times 5 is 20. So Mr. Patel's original number was 20. Now we can check that using the question. We were told that Lee finds half of the number. What is half of 20? If we split it into 2, it is 10. We already know, because we've worked it out, that Kim found a quarter, which is 5. And Lee's answer was 5 more than Kim's. Is 10 5 more than 5? Yes, it is. And that is because we know our equivalent fractions. We can see from the middle line here that 2 quarters are the same as a half. Okay, well done. That is the orange questions done for today. So let's have a little look at the blue questions. Okay, so we're following the same theme as we normally do, but the numbers have got a little bit more challenging. So again, we're going to look at our less than, greater than, and equal signs to make these number sentences correct. But this time, we're not going to work out what any of them equate to. We're just going to use our number knowledge of multiplying and dividing and place value to decide which one must be greater. So in the first one, we have 9 times 7 on one side, and we have 8 times 7 on the other. So without working out your 9, 7 or 8 times table, think about what we've got here. This is so many lots of 7, and this is so many lots of 7. So without working it out, I know I have 9 groups or 9 lots of 7 here, and 8 groups or 8 lots of 7 here. Well, that means I have one more group over here because 9 is greater than 8. And as the rest of the calculation is the same, I know this side must be bigger. So we're going to use our greater than symbol because we have 9 lots over here and 8 lots over here. So we have one more lot of 7, or this number will be 7 bigger than this number. Okay. What about the next one? We've got 48 divided by 2, and then we've got 48 divided by 4. So remembering that dividing means splitting into equal groups or sharing into equal groups, both calculations start with the same amount. Now in this one, if I start with my 48 cards here, my 48 football cards, I have to split them between 2 people. Okay, so I'm splitting into 2 equal groups. Over here, I still only have 48 cards to start off with, but this time I have to split it into 4 equal groups. So because I am splitting it into more groups, each group is going to have less in it. If I share my cards with me and my brother, we'll get more than if I also have to share those cards with you and your brother. So this one is going to be smaller, or this one is going to be bigger. So we're going to use our greater than symbol again, because as we are splitting it into less groups, each group has more in it. Okay, and then lastly, this one might look a little trickier, but we can work this one out. We have 300 times 2 on one side, and we have 20 times 30 on this side. Well, if I have a look at this, I can see that some of my digits are the same. I have a 3 in the hundreds over here, a 2 in the ones, and I have a 2 in the tens and a 3 in the tens over here. Now, sometimes when we've been doing our large multiplication, we've remembered to look at it as the first digits and then multiplying it up by the place value required. So let's have a think. The 300 on this side, if we go to the 30 over here, we know, and in fact, let me create some space on the whiteboard, that to get from 300 to 30, it has got 10 times smaller, or it has been divided by 10, hasn't it? We've gone from 300 to 30, so the decimal point has moved and we've divided it by 10. But let's think about what happened to get from 2 to 20. So 2 has gone from the ones column into the tens column, or the decimal point has moved this time to the right, not the left. So we have times it by 10. So if we divided one part of our multiplication by 10, but we times the other part of our multiplication by 10, well, then these two cancel back out to 0 because we divided by 10, then times by 10 again, which works back out at 0, which means that both of our calculations are going to be equal. This is balanced and we need an equal sign in the middle. And if you don't believe me, we can work out what it equates to prove it. So over here, if I do 3 times 2, I get 6. And then I need to multiply my answer by 100, or use those 2 zeros in the place value to make 600. Over here, if I do 2 times 3, again it is 6. Then I'm going to times it by 10. And I'm going to times it by another 10. And you will see that on both sides of my number sentence, I have 600. So we need an equal sign. Brilliant. Okay, let's move on to question 2. So we have, there are 1,500 children in a school. 565 of the children are girls. How many more boys than girls are in the school? So this is exactly like the orange question, but slightly bigger numbers. So let's do it the same way. Let's think about our whole bar being the school. And we know how many students there are in total. There are 1,500 students in the school. We know that 565 of them are girls, but we need to work out how many are boys. And we know that we are doing a subtraction. Okay, now we can write this out as a column subtraction. And we're going to have to do a bit of regrouping. So 0 take away 5 we can't do. So we come to borrow from the tens, but there's a 0 in there. So we have to borrow from the hundreds. Our 5 becomes a 4, and that 1 moves into the tens column because it cannot jump a place value. Now that we have 10 in here, we have got some to borrow from. So our 10 becomes a 9, and we get a 10 at the end. Now we have 10 take away 5, which is 5. We have 9 take away 6, which is 3. We have 4 take away 5, Again, 4 is too small. We have a small number on the top. So we borrow from the 1, making it a 0. And now we have 14 take away 5, which is 9. We were left with 0 in the thousands, so that's it. 935 boys. Another way in which we could have done that is thinking, well, I started with 1,500, and I have to take off 565. If you want to practice your number bonds, you can think, well, if I take the 500 off, I get down to 1,000. Then you need to take the 60 off. You've got to remember here, you're taking it off of basically 100. The next 100 before 1,000 is 900. So if you take 60 off, it becomes 940. And if you take your final 5 off, 935. Okay, but I've worked out how many boys, but the question didn't ask me how many boys. It asked me how many more boys than girls. And we remember now from the last one, how many more is looking for the difference between these two numbers. So we need to take the number of girls away from the number of boys. So we will use column subtraction again this time. So 935, take away 565. Okay, so we'll go start with our units again. 5 take away 5 is 0. 3 take away 6. Because our smaller number is on top, we can't do this. So we borrow from the 9 to make 8. 13 take away 6 is 7. And 8 take away 5 is 3. So there are 370 more boys than girls. Okay, and we are on to our last question of day 11. Well done for sticking with me. So we're back to Mr. Patel's mystery numbers on the board. So Mr. Patel writes a number on the board. Leon finds half of the number. Sophie, oh, I'm in this question, finds a third of the number. And Leon's number is 7 more than Sophie's. So what is the number that Mr. Patel started with? Again, they've given us a bar model to help. So I am going to start off by drawing out their bar model. And again, we will label it with what we know, just like we did in the orange question. So, again, I've copied their bar model. I've got a red line and a red bar and a green bar. So we know that Mr. Patel's number is the length of the whole bar. Mr. P's mystery number is the length of the whole bar. Leon found half. So Leon can be labelled in one red box. Sophie finds a third. So Sophie can be labelled in one green box. And Leon's number is 7 more than Sophie's. So it is the difference between the end of Sophie's and the end of Leon's, or this black line here, is 7. Okay, now because my drawing isn't particularly accurate, having used a ruler, you might not be able to see how that 7 is useful because it's not worth a whole box. But let's think about our fractions. We're working in halves and thirds. Now, if we were doing any work in comparing those fractions, we like to have what we call a common denominator, don't we? A number on the bottom is a denominator of a fraction. And a common denominator means that both fractions, we could find their equivalent using that. So now we need to think about our times table knowledge. Think about what number is a multiple of 2 and a multiple of 3. The opposite way of saying that is which number has 2 and 3 as common factors. So have a think about your 2 times table. Have a think about your 3 times table. What number is the first number you find in both, or the lowest common multiple? Well, actually, if you times them by each other, you'll find 6. So we could work in 6. So I'm going to change my bars slightly and I'm going to divide them into 6. I know that for the thirds, that means I just need to divide each box in 2. And I know for the halves, that means I need to divide each box in 3. Okay, so now I've put some blue dotted lines down. What do we notice about that 7? Or what is the difference between a third and a half? Well, the difference is 1/6, which is the 7 here. So if we know that 1/6 is 7, that means every sixth is 7. So if I label them all with 7 here, what could we do to figure out Mr. P's original number? That's it. We could do our 6 lots of, or 6 times 7. If some of you are finding that tricky to do in your head, do write them all down. Or here's a trick, because you all know your 5s. 5 times 7 is 35. And we just want one lot more. So we're going to add another lot of 7 onto 35. And we will find that Mr. Patel's original number is 42. Again, if you want to make sure you've got it right, you then plug that into the original question and see if it works. So Leon finds half the number. So half of 42 means I split it in 2, which would be 21. Sophie finds a third of the number. So that means I have to divide it by 3, which is a little bit trickier, but I know that 10 lots of 3 are 30. And that's 12 left over to 42, which is 4 lots of 3. So must be 14 for Sophie's number. So if Leon's number is 21 and Sophie's number is 14, is the difference between these two 7? It is. So we know we got it correct and Mr. Patel's number was 42. Fantastic. Well done for staying focused all the way through those. The questions are getting a little bit more challenging now. I will be back with day 12 very, very soon. Look forward to seeing you all soon. Thanks for watching. Bye.